Okay, so today's video is going to be about something interesting which is combination or which is in both, which is in two fields, physics and computer science. This topic is in both fields, and then it's the name of the topic is, and so the topic is logic gates. Okay, in logic gates, what first of all, you would say that logic gates are in physics, right? Yes, they are from the physics, because what does logic gate logic gates are nothing but semiconductors. So they are from electronics or digital electronic physics, but physics, engineers engineers make it, but are used in CS. So CS uses them to make logical statement in computers. Okay, so we can say in terms that hardware is physics, but algorithm 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 is CS. Okay, so my main focus is to talk about the logic gates, what the logic gates actually do. Then I will combine this with quantum mechanics or quantum computing. Okay, so first of all, we'll talk about a NOT. I'll just go through all the gates in one page. NOT, OR, AND, NAND, and XOR. These are all the gates in normal physics, and they are studied mostly in high schools or in secondary. So first of all, NOT gate. But the term NOT gate, we know that this is how the symbol looks like for NOT gate. Symbol. What NOT gate does is, if we have input A, NOT gate only has one input A and one input output and one output. Okay, output. So if input is A, output is not, but the word not, we can know that if we have something known as 0, if the input is 0, it will take the inverse or the opposite of that number, which is 1, or in binary, because we have only 1 and 0. So if we have 0, I would say inverse of A. Okay, it will take inverse of input. This is what it takes. Okay, then if we further solve, if we have 1, then we will have 0. It's the opposite, vice versa. NOT gate is not that hard. Then we have OR gate. Symbol is, first of all, this is what the symbol looks like. Don't mind my symbol. A and B output. And the second thing is that only NOT gate has one input. Other than that, all the gates has more than one input. Okay, OR gate is addition. We will say it's addition type. Output is equal to A plus B. Okay. Okay, one more thing. These are called truth tables. Truth table. A, B, output. A0. Okay, for the inputs, we'll just make of our own inputs for the better clarification. 1010. Okay. OR gate here is if either one of them is 1, the output we will get is 1. Either one of them is 1, the condition is if one or if either A or B is 1, we'll get output 1. If neither of them is there, then we know that's 0. 1 1. So here I OR gate either one of them is 1. Here when we say A plus B, some people say this is 2, not 1, but here we're talking about Boolean algebra. There's something known as a branch in physics which is Boolean algebra. It's a branch of physics on which these things work. Then we talk about AND gate. AND gate is opposite of OR gate. AND gate type of D, right? We can say this is a D. So again, two inputs and one output. Of course, output will be 1. Here, A, B output. 0 0 1 1 0 1 0 1. Okay, now again, AND gate is when both are 1, the output will be 1. Either it will be none. So that means 0 0 0 1 is 0 1 0 is 0 1 1 is 1. So if one of them is 0 or if one of them is 1, still the answer will be 0. But if both are 1, then you'll get 1. That's NAND gate or AND gate. It's not, these are not that hard gates. So that's why I'm not taking that much long. By the way, the amount of lines over here, the amount of, what do you call these, columns and rows we make depend on the amount of inputs we have. If we have input is to get that input, we do something known as 2n, 2 to the power n. The n is the number of inputs. N is number of inputs. So we'll know how many columns we'll make in that truth table. If we have 3 inputs, it will be 2 to the power 3, which is 2 times 2 times 2 is 8, and so on. Here it's, I think I have done 4 and 1. Yeah, so it's perfect. Here I have 2 inputs, so 2 to the power 2, which is 4. AND gate we studied, then NAND and XOR. NAND here. Wait, did I study? No, NAND. Yeah. NAND gate. NAND gate here. You might have heard, saw by the thought by the name. NAND gate is nothing but combination of now not and or, not and it's correct. Yes, that's how it is. If I draw the symbol, not and. Then how the symbol looks like. Here, what we have is NAND gate. Okay, wait. NAND gate, the combination of NAND gate is, if I draw its parts, separately parts, it is these two first and then not. It does make sense that why not a not is first and is second. Sorry, first and not is second. Here, bec- we can first of all see by the parts itself that AND gate needs two inputs, not one out input. Because even if we shift it to the side, it would be like this, and this is wrong because AND gate will have only one input. So we need two inputs. Second of all, we could say a NAND gate in terms that, let's suppose we can say not followed by AND. In this term, we can also like make a sense. Wait, I don't have space, so I'll just go with this. Again, two out inputs and one output. Again, I'll make 4 1 2 3 4 0 0 1 1 0 1 0 1. Okay, here NAND gate, let me make one small one over here for simplicity. Okay, NAND gate, first of all we'll do the 0 first. Wait, I should have 3 inputs, sorry, not 2. Here we have 3 inputs because we have 3 uh yeah, then it would be 2. Yes, as a combination. So 0 0, that's for 0 0 is 0, but not get turns into 1, so 1. And then 0, I'm doing this one for now to save time. 0 1 is again 0 because it should be both to get 1 0 and this one again. And 0 1 is again 0 and then 1. And 1 1 is 0 and 0. Sorry, 1 1 is 1 and 0. Okay, yeah, that's how it works, the NAND gate. And this is what the symbol looks like. If you have the symbol and you know what the components of NAND gate, by the word NAND gate, you know what the logic gates has, you can easily do the question of that. And XOR gate. XOR gate is the last one we'll study. I think I'm missing one gate, but we'll not talk about that for now. I think it's NOR gate. Yes, I didn't talk about NOR gate. It's the combination of NOT and OR. Okay, so XOR gate is exclusive. It it has the word exclusive in it. Zero zero one one zero one zero one. Okay, for exclusive, I wrote it's A exclusive B. Here for the simplicity, we'll just use A exclusive B. So A exclusive B is mean when if A exclusive B, if 0 exclusive 0, we'll get 0. Which one was that? If all are 0. Yeah. If both are 0, if both inputs are 0 or 1, we'll get 0. That's how NOR gates work, XOR gate works. XOR. Here, if one of them is different, it will be different for other as well. Here, but for one more thing, I'll make a truth table for 3 inputs so that we could know the difference of uh, difficulty because of this is being the last input. Last gate we'll study. A, B, C, out. So 0 0 1 1 0 1 0 1 and 1, sorry, 1 0 1 0. I'm just making up my own things, my own numbers, these combinations. So A exclusive, this will be changed. It will be A exclusive, not change. It will just, will adjust this one. So we have A exclusive, B exclusive, C. So it will be solved in pairs. First these two, then these two. The answer of these two will be done with these, the C. 0 exclusive 0, but both are same, we get 0. And 0 exclusive 1, different, so 1. When different, we'll get 1. So 0 exclusive 1, both are different, so 1. And 1 exclusive 0, different, so 1. 1 exclusive 0 is 0. 0 exclusive 1 is 1. Different. So, wait. 0 exclusive 0 is 1. And 1 exclusive 1, oh wait, sorry. This is different, yeah. 0. Because 0 exclusive 0, both are same, so, wait, no. They're same, sorry. 0 exclusive 0 is again 0. And 0 and 1. They both are different, so 1. 0 exclusive 1 is 0. And sorry, 1 and 1 exclusive 0 is 1. 1 exclusive 0 is 1. And 1 exclusive 1 is, they're different, right? So 1 and 1 exclusive 1, same, so 0. It's good to verify again. 1 exclusive 1 is same, so 0. And 0 exclusive 0 is again 0. Here, this is a truth table for that. First do these two, then do these two. These are all the gates. One gate is missing, so we don't need that for now. These are gates which are in normal CS and physics. Then learning them separate is easy, but when we get to the combination part, that's the hardest point, because the statement